Let's start with a review of MLOps foundations and architecture on AWS. MLOps pipeline design with SageMaker pipelines. What is the primary purpose of using SageMaker pipelines in an MLOps workflow? Is it A, to manually configure each step of the ML process? B, to automate and streamline the ML workflow? C, to provide a graphical interface for data labeling? Or D, to replace the need for data scientists? The answer is B, to automate and streamline the ML workflow. SageMaker Pipelines is designed to automate and streamline the machine learning workflow, including model training, tuning, and deployment, making it easier to manage and scale ML operations. In the context of CI/CD/CT with SageMaker pipelines, what does CT stand for? Is it A, continuous testing, B, continuous transformation, C, continuous training, or D, continuous tuning? The answer is C, continuous training. Why this question may seem a bit tricky, CT in MLOps often confuses people as it stands for continuous training, not continuous testing, or other similar terms. A data scientist is using SageMaker pipelines to automate model deployment. They notice the model performance drops after deployment. What should they focus on improving? Is it A, model training parameters, B, data preprocessing steps, C, deployment infrastructure, or D, continuous monitoring? The answer is D, continuous monitoring. The scenario suggests a need to monitor and adjust the model post-deployment, indicating a focus on continuous monitoring to maintain performance. Which component of SageMaker pipelines is responsible for defining the sequence of steps in a machine learning workflow? Is it A, pipeline, B, model, C, endpoint, or D, notebook? The answer is A, pipeline. A pipeline in SageMaker pipelines defines the sequence of steps, allowing for automation and management of the ML workflow. An MLOps engineer needs to ensure that their SageMaker pipeline automatically retrains models when new data is available. Which feature should they utilize? Is it A, manual execution, B, event-driven triggers, C, scheduled jobs, or D, batch processing? The answer is B, event-driven triggers. To automate retraining with new data, the engineer should use event-driven triggers, which initiate pipeline execution upon data changes.
Have you noticed the code in the bottom corner? Next time you're stumped, take that code to Birdsy.ai for immediate help and a free study session with Birdsy, your personal AI study partner. Plus, you'll get access to hundreds of additional questions, helping you move closer to passing your exam with confidence. The next time you're feeling unsure or stuck, give it a try.
What is the role of SageMaker pipelines in an MLOps workflow? Is it A, to store large data sets for training, B, to automate and manage machine learning workflows, C, to provide real-time predictions, or D, to visualize model performance metrics? The answer is B, to automate and manage machine learning workflows. SageMaker pipelines orchestrate the steps involved in machine learning workflows, ensuring seamless integration and automation of tasks like data preprocessing, model training, and deployment. In a SageMaker pipeline, what is the primary function of the processing step? Is it A, to deploy the trained model, B, to train the machine learning model, C, to preprocess or post-process data, or D, to evaluate model performance? The answer is C, to preprocess or post-process data. Why this question may seem a bit tricky. The term processing step might suggest any type of processing, but it specifically refers to data preprocessing or post-processing tasks within the pipeline. A data engineer needs to ensure that their SageMaker pipeline automatically triggers a new model training when the dataset is updated. Which feature should they implement? Is it A, AWS Lambda to trigger pipeline execution? B, manual execution of the pipeline? C, scheduled pipeline runs using AWS Batch? Or D, using SageMaker Model Monitor? The answer is A, AWS Lambda to trigger pipeline execution. Using event-driven triggers like AWS Lambda can automate pipeline executions based on data changes, ensuring timely model retraining. Model packaging, deployment strategies, and AWS architecture choices. What is the primary purpose of using Amazon SageMaker for model deployment? Is it A, to store large datasets? B, to provide scalable and managed infrastructure for model deployment? C, to create custom machine learning algorithms? Or D, to manage user authentication and authorization? The answer is B, to provide scalable and managed infrastructure for model deployment. Amazon SageMaker is designed to simplify the process of deploying machine learning models by providing scalable and managed infrastructure. Which AWS service is best suited for deploying a model that requires real-time predictions with low latency? Is it A, Amazon SageMaker, B, AWS Batch, C, Amazon S3, or D, AWS Lambda? The answer is A, Amazon SageMaker. While this question may seem a bit tricky, AWS offers multiple services for model deployment, but only Amazon SageMaker is optimized for real-time, low-latency predictions. A data scientist needs to deploy a machine learning model that will be accessed by thousands of users simultaneously. Which AWS architecture choice should they consider? Is it A, deploying on a single EC2 instance? B, using AWS Lambda with API Gateway? C, Amazon SageMaker with auto-scaling endpoints? Or D, storing the model in Amazon S3? The answer is C, Amazon SageMaker with auto-scaling endpoints. Using Amazon SageMaker with auto-scaling endpoints ensures the model can handle high traffic by scaling resources as needed. What is a key advantage of using AWS Elastic Beanstalk for deploying machine learning models? Is it A, it provides built-in machine learning algorithms? B, it offers real-time data analytics? C, it integrates directly with Amazon S3 for data storage? Or D, it abstracts infrastructure management for easier deployment? The answer is D, it abstracts infrastructure management for easier deployment. AWS Elastic Beanstalk simplifies deployment by managing the underlying infrastructure, allowing developers to focus on application logic. A company wants to deploy a model with periodic updates and minimal downtime. Which AWS service should they use to achieve this? Is it A, AWS Glue, B, Amazon SageMaker, C, Amazon RDS, or D, AWS CloudFormation? The answer is B, Amazon SageMaker. Amazon SageMaker allows for endpoint updates with minimal downtime, making it suitable for periodic model updates. A startup is deploying a machine learning model that needs to handle dynamic scaling based on user demand. They want to minimize operational overhead while ensuring high availability. Which AWS service should they choose for deployment? Is it A, Amazon EC2, B, AWS Elastic Beanstalk, C, AWS Lambda, or D, AWS Batch? The answer is C, AWS Lambda. AWS Lambda allows for automatic scaling and high availability with minimal management, making it ideal for dynamic workloads. Elastic Beanstalk and EC2 require more management, while AWS Batch is for batch processing.
Finding this exam review helpful? If you haven't already, like and subscribe for more videos that'll get you ready to pass.
Security, IAM roles, permissions boundaries, and least privilege patterns. What is the primary purpose of using IAM roles in AWS MLOps environments? Is it A, to grant temporary access to AWS resources, B, to permanently assign permissions to users, C, to manage billing and cost allocation, or D, to encrypt data in transit? The answer is A, to grant temporary access to AWS resources. IAM roles are used to grant temporary access to AWS resources, ensuring that users and services have the necessary permissions without sharing long-term credentials. In AWS, what is the common misconception about permissions boundaries? Is it A, they are used to grant additional permissions, B, they limit the maximum permissions a user can have, C, they are automatically applied to all IAM users, or D, they replace the need for IAM policies? The answer is B, they limit the maximum permissions a user can have. Why this question may seem a bit tricky. Permissions boundaries limit the maximum permissions a user can have, but they do not grant permissions themselves. A data scientist needs to access an S3 bucket for a project. What is the best practice to ensure least privilege access? Is it A, grant full admin access to the data scientist, B, use a shared IAM user with S3 access, C, assign an IAM role with specific S3 access, or D, add the data scientist to a group with broad permissions? The answer is C, assign an IAM role with specific S3 access. Assigning an IAM role with specific S3 access ensures the data scientist only has the permissions necessary for their task, adhering to the principle of least privilege. A team is setting up an MLOps pipeline on AWS. What is a common pitfall when configuring IAM roles for the pipeline? Is it A, not using IAM roles at all, B, using roles with no permissions, C, assigning roles to individual users, or D, over-provisioning roles with excessive permissions? The answer is D, over-provisioning roles with excessive permissions. Why this question may seem a bit tricky. Over-provisioning roles can lead to security vulnerabilities, as it grants more permissions than necessary. Model training, tuning, and feature management. Training workflows, distributed training, and cost optimization trade-offs. What is the primary benefit of using distributed training for machine learning models? Is it A, faster processing of large datasets, B, reduced need for data pre-processing, C, improved model accuracy, or D, simplified model deployment? The answer is A, faster processing of large datasets. Distributed training allows for faster processing by dividing tasks across multiple machines, which is crucial for handling large datasets and complex models. In a distributed training setup, what is a common trade-off when increasing the number of workers? Is it A, decreased model accuracy, B, increased communication overhead, C, reduced training data requirements, or D, simplified error handling? The answer is B, increased communication overhead. Why this question may seem a bit tricky. Increasing workers can lead to communication overhead, which might offset gains from parallel processing. A data scientist is optimizing a model training workflow to reduce costs. They decide to use spot instances for training. What is a potential risk of this approach? Is it A, increased training time, B, higher operational costs, C, unexpected instance termination, or D, limited scalability? The answer is C, unexpected instance termination. Spot instances can be terminated unexpectedly, which may interrupt training and require checkpointing to avoid data loss. Which of the following is a key consideration when tuning hyperparameters in a distributed training environment? Is it A, data normalization, B, model architecture selection, C, batch size adjustment, or D, synchronization of updates? The answer is D, synchronization of updates. Synchronization of updates across nodes is crucial to ensure consistent model updates and convergence. During a cost optimization review, a team decides to switch from on-demand to reserved instances for their training jobs. What is a likely benefit of this decision? Is it A, increased flexibility in scaling, B, reduced long-term costs, C, improved model performance, or D, faster instance provisioning? The answer is B, reduced long-term costs. Reserved instances offer cost savings over on-demand instances, especially for long-term predictable workloads. What is a primary consideration when choosing between synchronous and asynchronous distributed training? Is it A, synchronous training always results in faster convergence, B, asynchronous training can lead to faster training times but may affect model accuracy, C, synchronous training is more cost-effective than asynchronous training, or D, asynchronous training requires more computational resources than synchronous training? The answer is B, asynchronous training can lead to faster training times but may affect model accuracy. Synchronous training requires all workers to be in sync, which can lead to delays if one worker is slow. Asynchronous training allows workers to operate independently, which can improve speed but may affect model convergence. A machine learning team is using distributed training to scale their model training process. They notice increased costs and want to optimize. Which strategy should they consider to reduce costs without significantly impacting training time? Is it A, increasing the number of workers to speed up training, B, switching to on-demand instances for more stability, C, utilizing spot instances to take advantage of lower prices, or D, reducing the size of the dataset to decrease training time? The answer is C, utilizing spot instances to take advantage of lower prices. Using spot instances can significantly reduce costs, but they come with the risk of being interrupted. This strategy requires careful management but can be cost-effective. Hyperparameter tuning, warm starting, and resource selection. What is the primary goal of hyperparameter tuning in machine learning? Is it A, to maximize model performance, B, to reduce model complexity, C, to minimize training time, or D, to ensure model interpretability? The answer is A, to maximize model performance. Hyperparameter tuning aims to find the optimal set of hyperparameters that maximize the performance of a machine learning model. Which method is least likely to be used for hyperparameter tuning? Is it A, grid search, B, random search, C, Bayesian optimization, or D, principal component analysis? The answer is D, principal component analysis. Why this question may seem a bit tricky. All options are valid techniques, but one is not typically used for hyperparameter tuning. Alex is using AWS SageMaker to train a model and wants to leverage previous training jobs to save time. What feature should Alex use? Is it A, hyperparameter tuning, B, warm starting, C, batch processing, or D, model checkpointing? The answer is B, warm starting. Warm starting allows Alex to use previous training jobs to initialize new ones, saving time and resources. What is a common challenge when selecting resources for model training? Is it A, ensuring data privacy, B. Choosing the right algorithm. C. Balancing cost and performance. Or D. Maintaining model interpretability. The answer is C. Balancing cost and performance. Balancing cost and performance is a key challenge, as more resources can improve performance but increase costs. Jamie is tuning hyperparameters for a neural network and notices diminishing returns with increased epochs. What should Jamie consider adjusting? Is it A. Increase the batch size? B. Add more layers? C. Use dropout regularization? Or D. Adjust the learning rate? The answer is D. Adjust the learning rate. Adjusting the learning rate can help optimize training efficiency and prevent overfitting.
Have you noticed the code in the bottom corner? Next time you're stumped, take that code to Birdsy.ai for immediate help and a free study session with Birdsy, your personal AI study partner. Plus, you'll get access to hundreds of additional questions, helping you move closer to passing your exam with confidence. The next time you're feeling unsure or stuck, give it a try.
Feature store design, ingestion patterns, and online-offline store confusion points. What is the primary purpose of an online feature store in machine learning workflows? Is it A. To store raw data for pre-processing? B. To provide low-latency access to features for real-time inference? C. To archive historical model predictions? Or D. To manage model versioning and deployment? The answer is B. To provide low-latency access to features for real-time inference. An online feature store is designed to provide low-latency access to features for real-time model inference, unlike offline stores, which are used for batch processing. In feature store design, why might one choose to use an offline store over an online store? Is it A. To achieve lower latency in feature retrieval? B. To support real-time model inference? C. To handle large volumes of data cost-effectively? Or D. To ensure data is always up to date? The answer is C. To handle large volumes of data cost-effectively. Why this question may seem a bit tricky. Offline stores are often chosen for batch processing due to their cost-effectiveness and ability to handle large data volumes, not for real-time access. A data scientist needs to update features in a feature store for a model used in real-time fraud detection. Which feature store type should they use to ensure minimal latency? Is it A. Online feature store? B. Offline feature store? C. Data warehouse? Or D. Data lake? The answer is A. Online feature store. For real-time applications like fraud detection, an online feature store is necessary to ensure minimal latency in feature retrieval. During a model training session, a machine learning engineer realizes that the features in the offline store are outdated. What is the best course of action to ensure the model is trained on the most recent data? Is it A. Switch to using an online feature store? B. Ignore the outdated features and proceed? C. Use a data lake for feature retrieval? Or D. Refresh the offline store with the latest data? The answer is D. Refresh the offline store with the latest data. Refreshing the offline store with the latest data ensures that the model is trained on up-to-date features, which is crucial for model accuracy. Model deployment, scaling, and monitoring. Real-time, batch, and asynchronous inference patterns. What is the primary advantage of using batch transform over real-time endpoints for model inference? Is it A. Faster inference times? B. Cost-effectiveness for large datasets? C. Lower latency? Or D. Higher accuracy? The answer is B. Cost-effectiveness for large datasets. Batch transform is more cost-effective for processing large volumes of data at once, as it doesn't require the constant availability of resources like real-time endpoints. In what scenario would asynchronous inference be preferred over synchronous inference? Is it A, when immediate response is critical? B, for small, quick tasks? C, when handling large requests without blocking? Or D, when low latency is essential? The answer is C, when handling large requests without blocking. Why this question may seem a bit tricky. Asynchronous inference is preferred when response time is not critical, allowing for resource optimization and handling of large requests without blocking. A company needs to process daily transaction data to update their fraud detection model. Which inference pattern should they use? Is it A, batch transform, B, real-time endpoint, C, asynchronous inference, or D, synchronous inference? The answer is A, batch transform. Batch transform is suitable for processing large volumes of data at scheduled intervals, such as daily transaction data. Which inference pattern is best suited for applications requiring immediate feedback to user interactions? Is it A, batch transform, B, asynchronous inference, C, scheduled inference, or D, real-time endpoint? The answer is D, real-time endpoint. Real-time endpoints are designed to provide immediate feedback, making them ideal for applications requiring quick user interaction responses. A startup wants to deploy a model that predicts stock prices and needs to update predictions every minute. What deployment strategy should they choose? Is it A, batch transform, B, asynchronous inference, C, scheduled inference, or D, real-time endpoint? The answer is D, real-time endpoint. Real-time endpoints are suitable for scenarios requiring frequent updates and low latency, such as minute-by-minute stock price predictions. Auto-scaling strategies, multi-model endpoints, and container image management. What is the primary purpose of auto-scaling in model deployment? Is it A, to adjust resources based on demand, B, to permanently increase server capacity, C, to reduce the number of models deployed, or D, to ensure only one model is active at a time? The answer is A, to adjust resources based on demand. Autoscaling adjusts the number of instances based on demand, ensuring efficient resource use and cost management. It helps maintain performance during varying load conditions. In a multi-model endpoint, power models typically loaded to optimize resource usage. Is it A, all models are loaded into memory at startup, B, models are loaded on demand, C, models are preloaded based on predicted demand, or D, models are loaded in a round-robin fashion? The answer is B, models are loaded on demand. Why this question may seem a bit tricky. The term loaded might imply all models are active, but they are loaded on demand to save resources. A company wants to deploy multiple models using a single endpoint to reduce costs. What strategy should they use? Is it A, deploy each model on a separate endpoint, B, use a single model endpoint for all models, C, implement a multi-model endpoint, or D, deploy models in a containerized environment? The answer is C, implement a multi-model endpoint. Using a multi-model endpoint allows deploying multiple models under a single endpoint, reducing costs and simplifying management. A data scientist needs to update a container image for a deployed model without downtime. What approach should they take? Is it A, update the image directly in production, B, use a rolling update strategy, C, deploy a new model version alongside the old one, or D, Implement a blue-green deployment. The answer is D. Implement a blue-green deployment. Using a blue-green deployment allows updating the container image with minimal downtime by switching traffic between environments.
Finding this exam review helpful? If you haven't already, like and subscribe for more videos that'll get you ready to pass.
Model monitoring for drift, quality, bias, and data integrity. What is the primary purpose of monitoring a deployed machine learning model for data drift? Is it A, to improve model training speed, B, to ensure the input data distribution remains consistent with the training data, C, to reduce the computational cost of model inference, or D, to enhance the interpretability of model predictions? The answer is B, to ensure the input data distribution remains consistent with the training data. Monitoring for data drift ensures that the input data distribution remains consistent with the training data, which is crucial for maintaining model accuracy and reliability. Why might a model show bias even if trained on a balanced dataset? Is it A, the model was trained with an imbalanced dataset, B, the model uses a simple linear regression algorithm, C, feature selection or pre-processing steps introduced bias, or D, the model was not tested on a validation dataset? The answer is C, feature selection or pre-processing steps introduced bias. Why this question may seem a bit tricky. A balanced dataset doesn't guarantee unbiased models. Bias can arise from feature selection, model architecture, or data pre-processing steps that inadvertently favor certain outcomes. A data scientist notices a decline in model accuracy after deployment due to changes in user behavior. What should be prioritized to address this issue? Is it A, increase the model's complexity to handle new patterns, B, reduce the model's prediction frequency, C, adjust the model's hyperparameters, or D, retrain the model with updated data? The answer is D, retrain the model with updated data. The priority should be to retrain the model with updated data reflecting current user behavior to restore accuracy and relevance. Automation, observability, and ML governance. Automation with code pipeline, code build, and event-driven workflows. What is the primary purpose of AWS code pipeline in an automation workflow? Is it A, to manage serverless functions, B, to monitor application performance, C, to automate the build, test, and release phases, or D, to store application data? The answer is C, to automate the build, test, and release phases. AWS Code Pipeline automates the build, test, and release phases of your application development process, enabling continuous delivery. In AWS Code Build, what happens if a build fails due to a syntax error in the code? Is it A, the build continues with a warning, B, the build stops and reports the error, C, the error is automatically corrected, or D, the build is marked as successful? The answer is B, the build stops and reports the error. Why this question may seem a bit tricky. Code build will stop the build process and report the error, but it doesn't automatically fix syntax errors. A developer wants to trigger a code pipeline execution whenever a new commit is pushed to a GitHub repository. Which AWS service should they use to achieve this? Is it A, AWS CodeStar Connections, B, AWS CloudTrail, C, AWS Lambda, or D, AWS CloudFormation? The answer is A, AWS CodeStar Connections. AWS Code Pipeline can be triggered by events from GitHub using AWS CodeStar Connections. An operations team needs to ensure that their code build projects automatically rebuild when a new version of a dependency is released. What should they configure? Is it A, AWS CloudWatch alarms. B. AWS code deploy. C. AWS step functions. Or D. Amazon Event Bridge. The answer is D. Amazon Event Bridge. Using Amazon Event Bridge, they can set up rules to trigger code build when a new version of a dependency is released. Experiment tracking, lineage, auditability, and SageMaker model registry usage. What is the primary purpose of the SageMaker model registry? Is it A, to store raw data for training models, B, to manage the lifecycle of machine learning models, C, to provide real-time monitoring of deployed models, or D, to automate the feature engineering process? The answer is B, to manage the lifecycle of machine learning models. The SageMaker Model Registry is designed to manage the lifecycle of machine learning models, including versioning, approval, and deployment status. In the context of experiment tracking, what does lineage primarily refer to? Is it A, the history and origin of data and models, B, the performance metrics of a model, C, the final version of a deployed model, or D, the automated deployment pipeline? The answer is A, the history and origin of data and models. Why this question may seem a bit tricky, lineage refers to the history and origin of data and models, not just the final model or its performance metrics. A data scientist needs to ensure that all changes to a machine learning model are tracked and auditable. Which feature of SageMaker should they use? Is it A, SageMaker Data Wrangler, B, SageMaker Feature Store, C, SageMaker Model Registry, or D, SageMaker Studio? The answer is C, SageMaker Model Registry. The SageMaker Model Registry is used to track changes and ensure auditability of machine learning models. Compliance, approval workflows, rollback strategies, and reproducibility. What is the primary purpose of an approval workflow in ML governance? Is it A, to automate model training processes, B, to ensure changes are reviewed and authorized, C, to roll back models to previous versions, or D, to increase model performance? The answer is B, to ensure changes are reviewed and authorized. Approval workflows ensure that changes to machine learning models are reviewed and authorized by appropriate stakeholders, maintaining compliance and quality control. During a model deployment, the team discovers a critical bug that affects predictions. What is the most compliant action to take according to ML governance principles? Is it A, continue with the deployment and fix the bug later, B, ignore the bug if it affects a small percentage of predictions, C, roll back to a previous stable version, or D, deploy a quick patch without approval? The answer is C, roll back to a previous stable version. Rolling back to a previous stable version ensures compliance and minimizes risk while addressing the issue.
Thanks for watching. If you found this exam review helpful, be sure to subscribe for more real-world practice and topic-focused study videos. And visit Birdsy.ai to start your free trial of Birdsy, your AI-powered study partner.